Hello everyone, this is a second video in the series of videos on the basic aspects of waves. I'd introduced you guys to just the real basic components and some of the nomenclature that we run into. And today I just want to make some of the propagation a little more intuitive, the concept of propagation a little more intuitive, and perhaps clear up any misconceptions there may be about the propagation. So when we talk about how a wave propagates, first of all, generally when I talk about a wave and a wave occurring, really what it is yes, it's a periodic disturbance, yes, it's propagating, but what is propagating? Is the medium or media that the wave may be going through propagating? And that is to say, or that is to ask, that if I have a wave of sound going through the air, is the air itself propagating along with that wave? Is that what the wave is? If I have a wave going through water, is the water itself actually propagating or moving along with the wave? Or metal, if a wave is going through metal, is the metal itself moving? Is the earth itself moving? We talk about perhaps an earthquake. Or is there maybe something a little less intuitive occurring? And in fact, there is something a little less intuitive occurring. And what's occurring is that there is a transfer of energy. And that's ultimately what a wave is it's a way of transporting energy from one place to another via the means or via the agency of a wave. And that's how the energy is transferred. So the energy is being transferred through the media, whatever it may be. The energy is propagating, the wave is propagating, moving, but the media itself is not really, or not necessarily propagating with the wave. So let's just go ahead and see if we can perhaps put some sort of intuition to what I just said. So what I'm going to do is I'm just going to draw some water here. Pretend this is some water. And maybe I have a little person in the water here, kind of bobbing along. Here he is. And I now have a wave occur on the water. So what's going to happen to my little guy on the water here when the wave comes? And let's say that the wave is propagating in this direction here. Well, the wave gets to the little guy, right, and the water is displaced. The water's going to move up. The guy's going to go up. And then the wave is also going to go down. I'm going to have the peak, that's what we call peak, and then the wave will trough, and the little guy will move down, and then the wave will keep on going. And the question I'm asking you is the water itself. Is that little guy in that part of water, is he literally moving along with the wave? Well, not really. Only thing that's really happening to the guy, he may move a little bit, but really the only thing that's happening to the guy is he's bobbing up, and he's bobbing down, and the wave continues on its merry way, and the guy stays there. And that's what's really occurring, is that there's this energy moving in the water. Yes, the amplitude occurs, the guy goes up, the guy goes down, but that energy keeps on moving, and the water itself doesn't propagate along with the wave. And the way that maybe I could look at this to bring some intuition is imagine that you're at a ball game, and let's just say that we're looking at the bleachers here, and maybe the field is down here, and we have our goalposts. Alright, so it's a pretty poor drawing, but anyway. And I've got all these guys in the bleachers here. All these guys, thousands and thousands of people, we'll say, in these bleachers, and they're roaring, and their team's doing well, and really kicking some butt here. And somebody gets the bright idea to do what? Well, I want to do a wave, right? And so he, boom, brings his or her arms up in the air, and maybe that happens right here, and those arms go up, and then they wave down, and then the guy next to him, his arms go up, and they go down, and so on and so forth, all until that wave propagates all the way through all of the people. They do the wave. Now, the question I would pose, or I would ask is this guy here, literally, during this wave, does he move over to here? Does this guy here have to move all the way down there? Absolutely not. The guy doesn't move. He waves. There's positive amplitude, if you want to look at it that way, negative amplitude. But he does not propagate. The wave propagates away from him through all those other people. And that's how we need to look at waves in real life, is that they're not necessarily moving the medium, whatever medium it may be going through. If you're listening to the train tracks, that metal isn't literally being torn away and moved along. Or when I'm talking to you, the gas molecules, there isn't some molecule that starts at my mouth and literally shoots all the way over to your ear, right? What's happening is the energy that I'm spewing out of my mouth, basically, I'm spewing energy. My vocal cords are vibrating and creating a wave of energy. And it's that wave of energy that propagates through the individual gas molecules until it gets to your ear across the room, say, and you hear it. That's what's occurring with a wave. And hopefully you guys find that a little more intuitive, because I didn't find that necessarily intuitive at that point. Just another quick point I wanted to bring up, and I just want to bring up the concept that there are two major types of waves. There are two types. There's our first type, we'll say, and our second type here. So the first type of wave is something called a traveling wave. A traveling wave. And this is like a wave of water, a wave of light, a sound wave. It pretty much kind of goes wherever it wants to. But there's also another type of wave. And it's a type of wave that doesn't move anywhere. It's a very important type of wave, believe it or not, and we call this a stationary wave, or sometimes we call it a bound wave. And the way I look at this is, imagine a guitar string, and you know that a guitar string is bound on a guitar. When I pluck that wing, or that string, excuse me, when I pluck that string vibrates, and obviously that vibration produces sound waves that go away. But the string itself, as it vibrates back and forth, it's a periodic disturbance, it's a wave, it doesn't go anywhere, it's bound in that spot. And this concept of a bound or stationary wave is actually very important when we talk about how electrons are working when they're bound in an atom, and the wave-like characteristics of electron. This concept of a standing wave becomes very important. Okay guys, I'm going to cut it off here. Thanks for hanging in there.